Hello, welcome back. Today we're going to be solving quadratic equations using square roots. The objective is that by the end of this video, you should be able to solve an equation that looks like this by undoing operations in SADMAP order. You need to know that to undo an exponent of 2, we need to take the square root of both sides of the equation. So to get rid of this squared on the x, the exponent of 2, we take the square root of both sides. This gives us x is equal to a positive 2. But there's an important piece of information you need to know. There is another solution that shows up when we take the square root of both sides. To bring this out, I ask you the question, is there any other number we can multiply by itself to get a positive 4? We can clearly see that positive 2 is a solution to x squared equals 4 because 2 squared equals 4. So this solution will check out, but is there any other number we can square to get a positive 4? The answer is yes. We can square, not square root. Square means an exponent of 2, a negative 2 to get a positive 4. So there are actually two different solutions, x is equal to 2 and x is equal to negative 2. This will always happen when we take the square root of both sides. We'll end up with a positive and a negative answer. You'll see this answer written in several different ways. You'll see it written as x equals 2 and x equals negative 2. You'll see it as x equals 2 comma negative 2. Or the shortest method of writing the two solutions is x is equal to positive and minus 2. All of these are different ways of writing the same two solutions, one of which is positive and one of which is negative. Again, the point you need to know from this is that to undo an exponent of 2, you take the square root of both sides. When you take the square root of both sides, you end up with a positive and a negative answer. So this is another important piece of information you need to know. When undoing a square, an exponent of 2 that is, we get a positive and a negative answer. So for another easy example, if you were asked to solve x squared equals 9, to do that we would get rid of the square by taking the square root of both sides. And we would get x is equal to positive and negative 3, which we will see written this way. We will see written as x equals 3 and x equals negative 3. And you'll also see the answer written as x equals plus minus 3. All of these are acceptable answers for the solutions to this equation. They're just different ways of writing the same thing. No, you do not have to write the answer in all three ways. You can pick just one of these ways to write your answer. It's up to you. So if you don't like the plus minus, you can use x equals 3, x equals negative 3. If that's writing too much for you, you can use x equals 3 comma negative 3. Again, the choice is yours on how you represent the solutions. But when checking your answer versus the answer key, know that these solutions will be listed in one of these three ways. Here's another key idea. What if the solutions to x squared equals negative 4? What I'm really asking is, what number can we square to get a negative 4? There are a couple ways we can look at doing this. One, we can use what we just got through learning. X squared equals negative 4. To get x by itself, we take the square root of both sides. We get x is equal to plus or minus the square root of negative 4. The problem is we do not know how to square a negative number yet. You're going to learn that in another class, not this one. So we actually cannot solve this equation. There's no real solution. That's one way to look at it. Another way to look at this exact same problem is you could start guessing and checking and seeing if you could find a number that squares to give you a negative 4. You might be tempted to say positive 2 squared equals negative 4, but that's positive 4. You might try negative 2 squared equals negative 4, but that's again positive 4. So there's no number that we can square to get a negative 4. That's why there are no real solutions. What you need to take away from this is that when we take the square root of a negative number, we get no real solutions. So when we're solving an equation and there's a negative number on the other side, if it looks like this, x squared equals any negative number, you're just going to write down that there are no real solutions. The way I'm going to solve equations in this video is to get all the variables on one side and the numbers on the other, combine like terms on both sides. I'm going to solve the equation in SADMAP order, that's going in the reverse or the opposite order of operations, and then if it's not too ugly of a solution, I'm going to check the solution. As a review, SADMAP represents the order of operations in reverse. The S stands for subtraction, A for addition, D for division, M for multiplication, E for exponents, and P for parentheses. All the problems in this video use the same basic process, but there are 6 types of questions and answers. It is very important that you watch and work all of the following problems. I'll show you how to work each one and then give you an example to try. Here's the first example I'm going to work out for you. Solve the following equation in SADMAP order. Again, to do this, we're going to undo subtraction and addition first. And I notice I can undo the minus 5 by adding 5 to each side of the equation. This gives me 2x squared equal to 13 plus 5 is 18. Then I'm going to undo division and multiplication by dividing both sides by 2. So I did the multiplication, 2 times x squared, by dividing both sides by 2. This gives me x squared is equal to 9. And then to get rid of the square, that's our exponent, I'm going to take the square root of both sides. And that's going to leave me with my final answer as x equals plus or minus 3, because the square root of 9 is 3. And remember, we get a positive and a negative answer, which I'm going to choose to write as x equals plus or minus 3. Here's a problem for you to try. Go ahead and work it out, pressing pause, and press play when you're ready to see the answer. I went and worked out the problem, and I got a positive and a negative 4 for the answer. By adding 8 to both sides, that was undoing subtraction by adding. Dividing both sides by 2, that was undoing division, or rather undoing multiplication by dividing. And then taking the square root of both sides to get rid of the exponent of 2. That was undoing the exponent. Here's our second type of problem. Notice that we have a number inside the parentheses with the x. That's going to change the way we solve the problem from the previous one. Still the same order of operations. We're going to undo subtraction or addition first by doing the opposite operation. You'll notice there's a minus 5 in parentheses and a plus 7 outside the parentheses. We cannot, I repeat, cannot get rid of that minus 5 inside the parentheses because it's stuck in parentheses and that comes last. But we can get rid of the plus 7 by subtracting 7 from both sides. I undid addition by subtracting 7 from both sides, giving us 2/3. X minus 5 squared equals 13 minus 7 is 6. Now I'm going to look for division or multiplication to undo. I notice I've got a 2/3 times the parentheses, so I'm going to undo that by doing the opposite operation. So again, I'm undoing multiplication by dividing by the fraction, same thing as multiplying by the reciprocal. So we multiply both sides by 3 over 2, multiply by 3 over 2. If you remember, 3 times 2 over 2 times 3 gives us 6 over 6. Now you don't have to write 6 over 6. You can actually just write 1 or don't write it at all. X minus 5 squared equals. Now to multiply the 6 by the negative 3/2, you have to put the 6 over 1. You multiply the top to the top and the bottom to the bottom, giving you 18 over 2. Let's go ahead and simplify that and make that look a little nicer and neater. 6 over 6 is 1, which you don't have to write. We're left with x minus 5 parentheses squared equals 18 over 2 is 9. Now, we've undid subtraction and addition. We've undone division and multiplication. Now we look at exponents. We can undo the exponent of 2 by taking the square root of both sides. That gives us x minus 5, because the square root and the square cancel, is equal to positive or minus the square root of 9, which means positive or minus 3. And here's where this problem is a little different from the previous one. Notice we've got a positive or minus 3, but x is still not by itself. There are two ways to work this problem. The easiest way for future types of problems is go ahead and get rid of that minus 5 by adding 5 to both sides. So if I add 5 to both sides, I get plus 5 and plus 5. I cannot add the 5 to the plus minus 3 because it's a plus minus. I'll show you how to do that here in a second. I get x is equal to 5, since it was a positive 5, plus or minus 3. We have to split this apart. Since we can combine 5 and 3, we have to split it apart, giving us two different answers. X is equal to 5 plus 3, and x is equal to 5 minus 3. That's our positive or negative answer. So we get x is equal to 5 plus 3, which is 8, and x is equal to 5 minus 3, which is 2. So we end up with two different answers. We can write it as x equals 8, x equals 2, or you'll see it written as x equals 8, comma 2. Here's one for you to try. Go ahead and pause the video, work it out, and press play when you're ready to see the answer. I went ahead and worked it out for you. I added 6 to both sides first to get rid of subtraction and addition. Then multiplied by both sides by the reciprocal outside of the parentheses to get rid of the 3/5. And I simplified it, and then I took the square root to get rid of the exponent, and was left with m plus 4 equals positive or minus 5, which I'm going to rewrite right over here. M plus 4 equals plus or minus 5. So I'm going to subtract 4 from both sides. Let me do that in another color. So we subtract 4. We get m is equal to negative 4 plus or minus 5, which we can split up as m equal to negative 4 plus 5, and m is equal to negative 4 minus 5, which gives us our final two answers. M is equal to negative 4 plus 5, which is 1, and m is equal to negative 4 minus 5, which is negative 9. For problems like these where you have whole number answers, if you have enough time, it's a great idea to go ahead and check your solutions. For a third type of problem, we're going to solve it. Notice that we've got x squareds on both sides. All that means is you need to choose which side you want the x squareds on. I'm always going to get rid of the smaller amount, so negative 4x squared is smaller, so I'm going to add 4x squared to both sides. Negative 3x squared plus 4x squared is just plain old x squared, or 1x squared, minus 7 equals 5. I'm going to go ahead and add 7 to both sides, giving me x squared is equal to 12. Take the square root of both sides to get rid of the exponent of 2, and we get x is equal to plus or minus the square root of 12. Now we cannot take the square root of 12 or simplify it yet. That will happen in a future class. So if you end up with a question like this is actually your final answer. X is equal to plus or minus the square root of 12. You leave it just like that. The square root stays like it is since we cannot take the square root of 12 yet. Go ahead and try this example on your own, pressing pause and press play when you're ready to see the answer. For this one, I would choose to, you could do it differently. I would choose to get rid of the minus r squared by adding r squared to both sides. Give me 5 is equal to 8r squared minus 6. Get r squared by itself by adding 6 to both sides, giving us 11 is equal to 8r squared. And then go ahead and divide both sides by 8, giving us r squared is equal to 11 over 8. And to get rid of the square, we're going to take the square root of both sides, giving us in the end r squared, I'm just going to change the order, sorry, r, is equal to plus or minus the square root of 11 over 8. We're going to leave our answer just like that, again, for this class. Here's our fourth type of problem, or rather type of answer. Again, we're going to solve in SADMAP order, so I'm going to undo the exponent of 2 first. Since everything's trapped inside the parentheses, we have to get rid of the exponent to get rid of the parentheses. So let's take the square root of both sides. The square root and the square cancel, giving us plus or minus the square root of 3 is equal to 2y minus 5. Now I still need to get y by itself, so we're going to add 5 to both sides. Notice I cannot combine 5 and the square root of 3. They're not like terms. One is a 5, one is a square root. So I have to write it as 5 plus or minus the square root of 3 is equal to 2y. To get y by itself in the end, we divide by 2, which means we need to divide both terms on the other side by 2. So we divide the 5 by 2 and the square root of 3 by 2, giving us our final answer, 5/2 plus or minus the square root of 3 over 2. It's a really ugly answer, but that is the solution. Now if you had a calculator, you could type that out in your calculator and you would get a couple of different decimals for your final solution. But for the purposes of this class, this will be a perfectly acceptable final answer. And try this one on your own, pressing pause and press play when you're ready to see the answer. Again, for this one, we're going to get rid of the square root or square first, so we don't need those parentheses. We take the square root of both sides, giving us plus or minus the square root of 5 is equal to 3m plus 7. We need to get rid of the 3 and the 7, so we subtract 7 first. Since I cannot combine the 7 and the 5, I have to rewrite it. Negative 7 plus or minus the square root of 5 is equal to 3m. To get rid of the 3, I divide all terms on both sides by 3, giving us our final answer, negative 7/3 plus or minus the square root of 5 over 3. For our fifth type of problem, we've got the following. So we're going to get rid of, or I'd rather get m by itself by going in reverse order. So I'm going to subtract 6 from both sides first, giving us negative 4/5 m squared is equal to negative 5. Need to get rid of that negative 4/5 by multiplying both sides by negative 5/4. Negative 4/5 and negative 5/4 gives us 1, basically cancels, giving us an m squared is equal to, we multiply top to top, bottom to bottom, we get negative 5 times negative 5 is positive 25. 1 times 4 is 4. To get m by itself, we take the square root of both sides, giving us m is equal to plus or minus the square root of 25 over 4. Here's the reason I chose this problem to give you. We can simplify the square root of 25 over 4. Since 25 and 4 have square roots, we have to simplify our final answer as m is equal to plus or minus. The square root of 25 is 5. The square root of 4 is 2. So there is our final answer. M is equal to plus or minus the square root, or plus or minus the 5 over 2. Here's an example for you to try. Go ahead and work it out, pressing pause, then press play when you're ready to see the answer. Alright, for this one we work it out much the same way. We're going to add 4 first to both sides, giving us 9 is equal to 64 over 9x squared. To get rid of the 64 over 9 off the x squared, we're going to multiply both sides by the reciprocal. 9 over 64, that cancels. 9 over 64, put 9 over 1, 9 times 9 is 81. Over 64 is equal to x squared. To get rid of the square, we take the square root of both sides, giving us x squared, x is equal to, the square root of 81 over 64 is 9 over 8, plus or minus. Because we took the square root of both sides, we get a positive and minus. The square root of the top was 9, the square root of the bottom was 8, giving us plus or minus 9 over 8. For our sixth type of problem, this one actually has the least amount of work in your final answer. We're going to solve it by going in reverse order. So we subtract 1 from both sides. 23 minus 1 is 22, equal to negative 11x squared. Divide both sides by negative 11 to get rid of the negative 11 times x squared. 22 over negative 11 is negative 2 equals x squared. To get rid of the x, or rather the square off the x, we take the square root. Now here's the issue. We do get x is equal to plus or minus the square root of negative 2, but there's a negative number in there. A negative number. If you remember way back to the beginning of the video, if you have a negative number inside your square root as an answer, that means something very specific. In this case, or in any case, it means no real solutions. Technically, we should write that as a complete sentence. There are no real solutions to this equation. I will accept no real solutions as the final answer. And the last and final problem, go ahead and work it out, pressing pause and press play when you're ready to see the answer. For this problem, you'll notice you've got r squareds on both sides of the equation, so I always get rid of the smaller amount. So negative 5r squared is smaller than negative r squared. So I add 5r squared to both sides, and I get 7 plus 4r squared plus 9 is equal to 2. I need to combine my like terms on the left-hand side, clean it up a bit, make it look simpler. So I get 4r squared, 7 plus 9 is 16. Subtract 16 from both sides to get r by itself. So we get 4r squared is equal to negative 14. Divide both sides by 4, and we get r squared is equal to negative 14 over 4. Could reduce that. R squared is equal to negative 7 over 2. But honestly, if you notice you have an r squared equal to a negative number, it's a dead giveaway. You're going to have a square root of a negative. That means that there are no real solutions.